side.
Double angle. 8, 6.
So the next example, you want us to memorize these?
They're on your formula sheet?
Or are you working on
Yep, yep. All right. How are you doing today? Great. Wonderful. Let's see here. These are all in your book and on your formula sheets. These are the double angle formulas. These two right here are your half angle. And these are your power reducing formulas. That's what we're going to talk about today. All right? Power reducing formulas. All right, so let's start out with the double angle formulas. let's go ahead and establish this first one. And I actually did this already, but I'm going to do it again because it goes really quick. So if we were to be asked what is sine of theta plus theta, using the sum and difference formulas from 8.5, we have a formula for sine of alpha plus beta. Remember that formula, sine of alpha plus beta? This would become sine alpha cosine beta plus sine beta cosine alpha. That's the formula from last class. So this would become sine theta cosine theta. In other words, since they're the same angle, it would be the same thing here. And then plus another one of those, and it would be exactly the same. And if we put those two together, right, they're identical, we get two of them. Right? So this right here, theta plus theta, sorry, I should have put this, is 2 theta. And that's where we get this formula from right here. So let me just make sure you understand that one way you could look at this formula is that if you ever have sine of the argument is 2 theta, there is a way to rewrite that so that in the new expression you have the arguments of your trig functions have gone from 2 thetas down to thetas, haven't they? Like the original expression, the argument was 2 theta. In the result, you have multiple trig functions, but the arguments of each one of them are now theta instead of 2 theta. And that becomes very useful when you're trying to convert an expression with 2 thetas to thetas instead. All right? Any questions on how I got that? Okay, let's try the next one. Let's try and establish this formula cosine of 2 theta. So I'll actually write 2 theta first. Then I'll write that as cosine of theta plus theta. And then I can use the formula from last class again, the sum difference formula. And the formula was, if it was cosine of alpha plus beta, it was cosine alpha, cosine beta, plus or minus. If this is a plus with the cosine formula, it's minus, right? So this will be cosine theta cosine theta. It's theta twice because it's the same angle. And then minus sine theta again. Same angle. Do y'all know what I mean by last class formula? If this was alpha and beta, that this would be alpha beta and then beta alpha. It doesn't matter here, you can switch the order. But since they're the same thing, it doesn't, you just get thetas the whole time. So what's cosine theta times cosine theta? Cosine squared theta. And then minus sine theta times sine theta is sine squared theta. Now, look, if this was a plus in here, then the answer would be 1, wouldn't it? Because that would be a Pythagorean identity. But this is subtraction. So cosine of 2 theta can be rewritten as cosine squared theta minus sine squared theta. Notice the arguments again are just thetas now, not 2 thetas. So if you ever needed to get from 2 theta down to theta, you could use this formula. Now, notice over in the formulas for cosine of 2 theta, I have this, and then I also have this and this. There's 3 equivalent expressions. They're all the same. With sine 2 theta, there's only 1, right? But with this one, there's 3 of them. Well, why are there 3 of them? Well, it's because you can kind of mess around with this a little bit and make it look like something else. If you go to the Pythagorean identity, the very important Pythagorean identity, right? This identity, I can replace, like I can solve this for sine squared, right? Couldn't I? If I solve that for sine squared, I get 1 minus cosine squared, don't I? Like that. So imagine coming over here and taking this, I'm going to box this because this is the answer. But imagine we wanted to do some more work with it. And imagine we have minus, and we replace sine squared with 1 minus cosine squared theta. Then what would that turn out to be? You have cosine squared theta minus 1. Then minus minus would be plus cosine squared theta. And so how many cosine squared thetas do you have? 2 of them, right? So wouldn't that be this one right here? That'd be this one. Yes? So we can get this formula also by just doing this and then replacing. Understand? How do you think I could get this formula? How do you think I'd get this one instead? Yeah, do this, come back over here, solve this one for cosine this time, cosine squared. And you get 1 minus sine squared theta. Then go back over here and replace cosine squared with 1 minus sine squared. And so if I have 1 minus sine squared theta minus sine squared theta, I'm going to have 1 minus 2 sine squared thetas. So I get this one. Okay? So everything is just, these three formulas are just slight like tweaks of one another. All right? Now, when would you want to use one over the other? Like if this can be three different things, like when do you decide which one to use, right? Because they're all the same? Well, I would use this one if I was interested in dealing with the signs, with just sines and not dealing with any cosines, right? Because this expression just has sines in it. I would use this one if I wanted to deal with the cosines because it doesn't have sines in it. And this one I would use if it didn't matter whether or not it's cosines or sines. Understand? Everybody seems, all my classes have just seemed like totally zoned out the last like day. Y'all all right? Spring break, coming back? Is this our first day from spring break? No, it's not, right? Okay, I was going to say. We've been back a while, haven't we? All right. Now, I've covered 2 of 6 formulas that we have for today. The others, I'm just going to say here they are, okay? I'm not going to derive these. It's just going to take too long. So this formula right here is a half angle formula. And what it says is if you have sine of an angle over 2, you can rewrite it like this. Now, can somebody tell me, like in terms of the argument, like I said here, the 2 thetas become thetas in the new formula. What happens in this half angle formula? What happens to my argument here? It goes from what? Half of theta. And in the new expression, the argument is what? Just theta. You see? That's cosine of theta. The whole thing is divided by 2, but not the angle. The angle is not divided by 2. So this formula allows you to take a half of an angle and turn it into a new expression that has just the angle not divided by 2. All right? There is a problem with this second formula, though. Plus or minus. That means there's 2 possible answers. And that's going to be somewhat problematic, as we're going to see. We're going to have to figure out which one is it. Is it the positive or the negative? It can't be both answers. It can only be one. Now, cosine of theta over 2, the formula is very similar, right? The only difference between these two is what? This is subtraction and this is addition, right? Yes? The way that I remember that, subtraction, sine, s, subtract, that's the way I remember it. So you have subtraction here, and here it's addition. Again, plus or minus, this will become something we have to deal with. Okay, so we can get from 2 thetas down to thetas. We can get from half thetas to thetas, right? Let's look at the last formulas. They're called the power-reducing formulas. In terms of the argument, what does the argument go from? The argument. Thetas to 2 thetas, right? But we call these the power-reducing formulas because what they allow you to do is start with something that is squared. So we have a sine of theta that's squared, right? And later on, especially in Cal 2, a lot of times you don't want to deal with the sine squared. You'd rather not have something squared to deal with. So what we do is we want to get rid of the squared. And notice on the new expression, there's no squared trig functions in here anymore. Do you see that? The squared went away. We have reduced the power. We have reduced that power from a power of 2 down to a power of 1. There was a give and a take on that, though, right? We got to reduce the power. What we give up is that we have to double the angle in the formula. So something has to give in order for everything to work out. Does that kind of make sense? You're going to see it when we work through the problems, but this is the expression that's in most formula sheets. What's the difference between this and this one? What did I do here? I took that 2 out the bottom and just looked at it as a 1/2 out front. Again, in Calculus 2, this is easier to work with than this, so I just write it like that. This one right here, same thing. Just pull the 2 out the bottom, it's a 1/2 in front. Also notice again that whole little subtract add is the only difference in these formulas. So S subtract, cosine is, you just have to remember, is add, all right? All right, so that's a lot of formulas, right? I'm going to leave all those on the board. Let's get an example going. If you did the homework for sum and difference formula, if you watched me do the homework, it was pretty ridiculous. But the most important thing, I think if there's anything from this, is that in the problems where you have to construct these triangles. That is the main part of what you need to be able to do, these reference triangles. So that's where I'm going to start. So what I'd like to do is take a look at, I'm just going to pull a problem from the book here that's not in your homework. This is number 10. It says, given here, that cosine of theta is equal to 3/5. And I'm going to change the problem a little bit. 3 pi over 2 is less than theta is less than 2 pi. Okay, that's given to you. You're given some information about cosine of some angle. You have no idea anything else about that angle. Here's what we want. Part A, find sine of 2 theta. Part B, find cosine of 2 theta. Part C, find sine of theta over 2. D, find cosine of theta over 2. E, find sine squared of theta. And F, find cosine squared theta. You know what? No, we won't do that yet. Okay, you ready? We got to do all those things. Now, keep in mind, all we know is about, the information we are given is about theta, right? Our argument is theta. What we're being asked for is information about twice that angle. So let's say someone gives us a certain angle. Cosine would be the x-coordinate, yes? That's not what we want, though. We want to say, what happens if you were to double that angle? Then what would be the y-coordinate? If you doubled that angle, what would be the x-coordinate? If you halved the angle, what would be the y-coordinate? If you half the angle, what would be the x-coordinate? What happens if you take the y-coordinate and square it? What happens if you take the x-coordinate and square it? Got it? Everything is going to be based upon, though, this piece right here. So I'm going to start with a triangle, reference triangle. That's where I'm going to begin my work. So I am in which quadrant? Fourth quadrant. That's given to me, right? So I know theta is in here. Theta is somewhere in here. So I can draw that little reference triangle that goes back to my x-axis like this. And my angle theta, that reference angle is there. And now what? Cosine, this right here, represents what over what on that triangle? Cosine is the x over r, right? So this is Or you could say it's the adjacent over the hypotenuse, right? So that means my adjacent side should be this side 3, and this side should be 5. And are the signs correct here? Is that a positive 3? Yes, because I'm to the right of, I'm going to the right, and then this is always positive. Okay, so we have some information about cosine theta being 3/5 gives us this, and then from this, we're going to construct this side. We just do our Pythagorean, and these, you've probably worked that enough to know that a 3, 4, 5 triangle is a, what we call a Pythagorean triple. It's one of those rare ones that, you get nice integers, okay? Anytime you have integer, 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 not decimals or roots, it's called a Pythagorean triple. So 3, 4, 5 is a common Pythagorean triple. There are an infinite number of Pythagorean triples. Okay. Now, why is it that I wanted this triangle? I mean, we need to kind of take a step back. Why do I want to make this triangle? Because this will tell me what sine theta is. But why do I need sine theta?
Because that's what A is asking.
What's that?
That's what we're looking for right now, right?
Well, A is asking for sine of 2 theta, not sine of theta. Right?
Yeah, we're just finding the one piece, and then we're going to put it into there.
Okay, so each of these formulas, right? Each of them involves, like sine of 2 theta involves both sine theta and cosine theta, right? How about cosine 2 theta? Did I need to do this work? If all I was asked in this problem is to do this, would I need this triangle? No, because to find cosine of 2 theta, I could have used which of these three would I want to use? First one, second one, or third one? The third one, because the third one requires you just know what? Cosine theta, which I was given, you see? So I wouldn't need to do all this work if all I wanted was this, right? But because I have to do this, I need both sine theta and cosine theta. How about these two? Would I need to do the triangle to do these two? No, because again, in these formulas, right, I only need cosine theta. Cosine theta, I don't need sine theta. How about over here? Well, in order to know what sine squared theta is, I actually need to know what cosine of 2 theta is, don't I? And cosine of 2 theta is my part B, right? So, all right, I'm trying to get you to see that the usefulness of this for this problem is really only for part A. That you could survive and get through the rest of these without any information about the triangle. Now, had I given you some information about sine of the angle instead, then you would have to do some work. There would be no way around it. You have to go figure out what cosine is. All right, so let's grind this out. Sine 2 theta should be 2 sine theta cosine theta. I'm just going to write the formula down. But that for us is what? 2 times, what's sine theta? Oh, y'all didn't, no one said anything. Oh, that's -4. Ooh, man, that would have been a bad situation. Why is it -4? Because you're in the 4th quadrant. Yes, a 3, 4, 5, it's a Pythagorean triple, but because the y coordinate is negative, it has to be -4. I'm going to get like 10 lashings in math hell for that. Okay, so sine of theta is opposite over hypotenuse, so -4/5. Okay, times now cosine theta, but cosine theta was given, 3/5. We're in business. Now you just multiply that. What is that? -24 over 25. That's it. Something to keep in mind. Remember that that sine and cosine, if you graph sine and cosine, they look like this, and they're bounded between -1 and 1, right? no matter what angle I ever plug into this, I should get an answer that's no bigger than 1 and no smaller or less than -1. Agreed? Negative 24 over 25 is a negative number, and it's almost 1. It's smaller than 1 though, right? If you get an answer here like -3, something is wrong, right? Your answer should never be outside of that range, -1 to 1. All right, let's do cosine 2 theta. So cosine 2 theta, I'm going to use that formula right there. So it's 2 cosine squared theta minus 1, which for us here is 2. And then what is cosine theta? What is cosine theta? Because I need to take cosine theta and square it. So 3/5 and then squared. So notice how I did that. Cosine theta is 3/5, and then I'm squaring it. And then I have -1. So let's just make sure we do order of operations correctly here. 3/5 squared, 9/25 times 2, 18/25. -1, get a common denominator. 18/25 minus 25/25. And we should get -7 over 25. Questions? Questions? Y'all are good? Okay. All right, let's try this one. Sine of theta over 2. Ooh. Equals. I'm going to need a little more room, so I'm just going to move down here. According to the formula, it's plus or minus square root of 1, it's sine, so it's subtract cosine theta over 2, which should be plus or minus square root of 1 minus 3/5 over 2. Agreed? Or not? So I'm using this formula here, plus or minus square root of 1 minus cosine theta over 2. And cosine theta, I actually know that because it was given to me. It's 3/5, so that's 1 minus 3/5 over 2. I go ahead and figure out what the numerator is. I get a common denominator and subtract. So what is this up there? 2/5 all over 2. And you can look at that 2 as 2 over 1 and then flip it. So what do you get there? Plus or minus square root of what? 1/5. Questions? We're not done. Any questions on that though? We're not done. The reason we're not done is because we're saying that if you take sine of half of this angle, your answer is 2 different things. And that can't be right. This should represent the y-coordinate, right, of half of the angle. Or yeah, the y-coordinate, if you take half the angle and the y-coordinate, it can't possibly have 2 different y-coordinates, right? So how do we actually resolve whether or not it's the plus or minus? Yep. You can just flip a coin. Just take a coin, flip it, and you're good. Yeah, we have to figure out where theta over 2 is. Where is this angle? Where is it? Well, here's how we do that. So to do that, let me just write underneath this, write down the original restrictions on theta. Weren't these the original restrictions on theta? I'm not interested in theta. I'm interested in theta over 2, aren't I? So what I'm going to do is I'm going to come in here, and you can do this with, when you have a string of inequalities like this, you can multiply or divide everything by the same number so long as it's not a negative number. So like, I can divide this by 2, divide that by 2, and I can divide this by 2. Let me do it like that. I can do that. I'm allowed to do that as long as I do it to each one, all right? So this new inequality looks like this. Theta over 2 should be less than pi, because those 2's cancel. And then when you do this and flip and reciprocate, you get 3 pi over 4. Okay, so if theta has to be between 3 pi over 2 and 2 pi, then half of theta has to be between 3 pi over 4 and pi. So where is that? Let me just draw a quick picture here. Where is that? Well, this is pi, right? Right there? Where's 3 pi over 4? It's in the second quadrant. So we're somewhere in here, aren't we? Between 3 pi over 4 and pi? That means we're in the second quadrant. If we're in the second quadrant and we are looking at sine is the y coordinate, we must be positive. Agreed? That's how that works. Do y'all kind of get that? Okay, so from this information right here, from all of this, and because we are talking about sine, the y coordinate, we know that this right here has to be the positive answer of root 1/5, not the negative. Questions? Let's do cosine of theta over 2. What's the only difference that I have in the formula?
Instead of it being negative, it's positive?
It's plus, right? So that's plus. So I'm going to go right to that. It's going to be plus or minus 1 plus 3/5 over 2. And that's going to be plus or minus root of, say, 8/5 over 2, which is plus or minus root 4/5. That's all I'm doing there. Is it plus or minus? Minus. This time it's minus because it's the same situation. Theta over 2 is still stuck between here and here. So we know we're between 3 pi over 4 and pi, but it's now the x-coordinate because we're looking at cosine. And because we're in that second quadrant, the x-coordinate must be negative. That means we're going to take the negative answer here. So negative root 4/5.
Can you explain that last part again?
Okay.
About getting negative?
Yeah, we want to know what the x-coordinate, right, is, because it's cosine. We want to know the x-coordinate at half of the angle. Well, if half of the angle has to be between here and here, right, then we've got to be somewhere in this quadrant. If I tell you to go to some point on that little arc, your x-coordinate is going to have to be negative to get there, right? The y-coordinate was positive. That's what gets us the negative. Negative x means cosine is negative. Positive y means that the sine was positive.
And I guess it all depends on the first thing that we're talking about. So like if we're talking about, or like we did with the previous problem, sine half of the angle.
Uh-huh.
That's what we did when you just half the...
Yes. I half the restriction that was given to us. Yep.
Okay, I got it.
And just remember y-coordinate, x-coordinate. Yep. Okay, so let me ask you. Let's say that part D right here. Let's say part D, let's say that you were grading it on a 10-point scale, all right? If the student left it blank, it would be 0. If they got it perfectly right, it would be 10. How much do you think should be taken off if this is incorrect, if the sign is incorrect, if this is like a plus instead of a minus or a minus instead of a plus?
Half a point.
Half of 1 point? What do you think? I'm just curious, like, do you think that's a big mistake? Okay, what if they leave plus or minus and they don't ever establish which one it is? Minus 1?
Minus an eighth of a point?
Because the answer is in there, right? Yeah, I don't know. That's a tough one for me to decide how much. I think it's a big deal. I think it's a big deal because if you just do this, all this tells me is you know how to read a formula. That's all that tells me. It doesn't show me that you understand how to resolve which of these it is. And I think that this is a pretty big deal in terms of big picture. Okay? So I don't know. We'll see. No one's going to make the mistake. Everyone's going to resolve it. So I won't even have to worry about it. Curious right now. It's not on here. I don't have it listed as a question, but let me put them in here just real quick. I'm going to add these before we do the next. I'm going to add a part G and a part H. Okay, so part G, I'd like to know what tangent of 2 theta is. And for H, I'd like to know what tangent of theta over 2 is. I never gave you formulas for these, right? They are in your book, but we're not going to use them. Because what is tangent of 2 theta just by definition? Tangent is what over what? It's sine 2 theta over cosine 2 theta, isn't that? So this is sine 2 theta over cosine 2 theta. Did we figure out what sine of 2 theta was? We did, didn't we? It was this. Negative 24 over 25 over, now cosine of 2 theta was negative 7 over 25. And what would happen if I did my flip reciprocate there? The 25s would cancel, the negatives would go away, you get a positive. And what would you have? 24/7? Is it okay that that number's bigger than 1?
Yes.
Yes, because it's tangent, right? Tangent is not bounded between -1 and 1. So that's okay. Y'all see what I did there? If you go and get sine of 2 theta and cosine of 2 theta, there really is no need for a third formula for tangent 2 theta. You just take the ratio of those two numbers and you're done. Now how about tangent of theta over 2? That one will be sine of theta over 2 over cosine of theta over 2. Do what?
That bit different?
That
You just did sine of theta over cosine of theta over 2.
cannot. Because then that half, you're basically pulling that half out, and you can't pull numbers out of arguments of trig functions. I think that's what you were doing. I don't know.
Probably.
Yeah. No, you have to take this answer and divide it by this answer. That's what you have to do. So let's take sine of theta over 2, which was erased. It was root 1/5, right? Root 1/5 over root, negative root, right? Negative root 4/5. And that might look bad, but it really isn't that bad because there is a property of roots where if you have root of something over root of something, you can turn it all into one big root. In other words, like this. You can say that this is equal to, now I'm going to put a negative out front because that negative down here is going to just act like a -1 out front. And then I'm going to put 1/5 over 4/5. So that's what I was saying. If you have a fraction with root on top, root on bottom, you can turn it into big root over with a fraction inside. And then just flip and cancel, and I think you get, what, 1/4 in there? So you just get negative root 1/4. All right, here we go. Continuing. I erased my triangle, but I'll draw it again. How do y'all feel about this so far? Okay, let me just draw that triangle again that we had. It was 3, -4, 5, right? That was my theta. All right, so let's look at this sine squared theta. I do have formulas for them, don't I? Yes? But do I really need them? Do I know what sine of theta is? So can I just square that answer? Yeah. Do I know what cosine of theta is? Sure, just square the answer, right? So tell me what sine of theta was off that. We're going off this, right? Okay, so sine theta was what? -4/5. And I'm supposed to square that, which gives me 16/25. Done. What is cosine squared theta? Well, cosine theta is 3/5. If I square that, I get 9/25. So those are the answers. Right? Now, out of curiosity, do you think we could get those same two answers using these formulas over here? We should be able to. Let's see if we can. Let's see if we can. Can we use that formula 1 minus cosine 2 theta over 2 to get the same result? Do you know what cosine of 2 theta is? We did that, right? That was part B? What did we get for part B? -7/25. It was negative? Okay, over 2. So y'all see what I'm doing? I'm using this formula. But I should get an answer of 16/25 when I'm done. Let's see if I do. This is the same as 1 plus 7/25 over 2. You have to get a common denominator up top. So 25 on top and bottom, and then add 7. You get 32 over 25 on top. But then all of that divided by 2. And when you do that and write that as 2 over 1 and flip it, what do you get? 16/25. So you get the same answer. So this is by far the easier way to go, right? But I'm just showing you how you could have used that formula to get it also. All right. I think we need to do another one that's not so nice where we had cosine here in the beginning, right? Let's do another one. Do you want me to let you try and work it? Do you feel comfortable enough to try it? Okay. Let's do this. I'm going to put the problem up here. I want everyone to initially start to just get that reference triangle drawn. Once you have your triangle drawn, raise your hand, I'll come check. You work with each other. Once the triangle is drawn, everything else should work out after that, right? I mean, everything else should fall directly from the triangle. We'll leave G and H up here. No, we won't. We don't need to do that. I just want us to do those. Let's actually take these out. Let's take the squares out because we saw those were kind of too easy. All right, so we're gonna do this. What happens if you mess up your triangle? It's all going to be wrong. Everything, right? All right, so how about this? Given that tangent theta is a half and pi is less than theta is less than 3 pi over 2. Find those 4 things. Y'all can work together or you can work alone, whatever you feel is. Like I said, when you get the triangle drawn, raise your hand. I can come by and check to make sure your triangle's good. I'll be right there. Do not let me forget. I've unmuted my microphone. I'm gonna start working it out up here, and then you can kind of look up here and see if you're getting the same thing.
Yeah, if you mess up the first time, you mess up. All right.
Sine times theta. One minus cosine theta, right? And you put in the negative 2 over root 5. Oh, idiot.
Sine is the one. And I what?
Oh, I remember.
Look, if you want to leave the answer as this, that's okay.
Okay.
All right? But to explain how I got to here, I got a common denominator. I rewrote this 1 as root 5 over root 5. And then put them together, and I got this. And then I divided by 2 over 1 and flipped the 2 over 1 like this, and the 2 just joins the bottom. That's it. But if you want to leave it like that, that's fine. But you still have to resolve the plus or minus. Okay, that's all. That's everything up there. Do you have any questions? Yes.
I do. You can come with
Yeah.
So, I mean, you use a different formula, but I use this one with -1. It gave me -3/5. How did you check that to verify that it's not
Which?
for cosine 2 theta?
So which formula did you use?
It was
2 cosine theta.
2
So
cosine.
2 times. But what's cosine theta? I think that's the problem.
Okay.
Cosine theta off of this triangle is -2/√5. I think you use sine. Because you put -1/√5.